Hello everyone. In this video, we are going to take a look at the problem of probability using a combination formula. A factory received a shipment of 33 compressors, and the vendor who sold the items knows there are 7 compressors in the shipment that are defective. Before the receiving foreman accepts the delivery, he samples the shipments. And if too many of the compressors in the samples are defective, he will refuse the shipment. So now we want to answer the following 2 questions. If a sample of 7 compressors is selected, find the probability that all in the sample are defective. Okay, so first thing is we draw a picture of the problem. Okay. So here we have the total of 33 compressors, okay? And we know that inside the 33 compressors, 7 of them are defective. So I know that 7 of the compressors are defective. And then, because we have a total of 33, therefore, 33 subtract 7, that would be 26. So we have 26 items that are non-defective. All right. So the first questions they ask you, find the probability. So anytime that you are finding a probability, you need a fraction. All right. You need a fraction because I'm looking for the ratio. Okay. So what comes at the bottom here is the total number of the possible choices. I have the total of 33. Now I take out a sample of 7 compressors in any order. So the order does not matter. It's not important. That means the total number of the possible outcomes, I have 33. I choose out 7. We use the combination formula because we don't care about the order. Okay, so there are 33 C7 possible choices for you to select out 7 compressors out of the 33. And now we want that all the items in the sample are defective. Okay. So what is the chance of you selecting all 7 of them are defective? We have 7 compressors being selected, and now we want all of them to be defective. That means we want to pull out all of them from the list of the defective items. We have only 7 defective items, and now we want all of them to be defective. That means we'll take 7 of them out of the 7 defective ones, and that is the chance of you getting that over the entire possible choices. All right, so 7, choose out 7. There's only one choice. There's only one choice to do that. 7 and take out 7. There's only one choice. And then 33, choose 7. We can use the graphing calculator to do that. So what we do here is we press 33 and then we go to math and we choose the PRB, probability, and then we choose the option 3, which is the combination formula, and then 7, and that will give you 4272048, which is the answer here, right? So 1 over that. Okay. Now, the second question, if a sample of 7 compressors is selected, 7 again, we only take out 7. Find the probability, that means we need a fraction, that none in the sample are defective. Again, the total number of the possible outcomes would be 33, we choose out 7. Because we have the 33 total, we take out 7, so this is the number of the choices that we can have. And then, for the top, we are looking for the chance that none in the sample are defective. So you don't want any of the defective items. So I'm gonna focus on the non-defective ones. We have 26 of them. And then now you want nothing to be defective. That means you want the 7 compressors being selected coming from the list of the non-defective, which is 26. So 26 choose out 7. And I can use a graphing calculator for this. I pick 26 and I go math, PRB, and I pick C, and 7 on the top will give me 657 800. 657 800. And then at the bottom I would have the same thing here, right? 3327, the same value. So 427 2048. And you can simplify this. You can simplify the fraction. You can take this value and divide by 427 2048. And you can go to math and click on fraction to convert this to a reduced fractions, which is in fact somehow the calculator doesn't do that for us, right? So we have to do it by hand. So we see that this is even number. So I'm just gonna go ahead and divide by 2 on the top. Then I have 32, 8, and 900, right? 32, 8, 900. We can do slowly, step by step. And then I can take the bottom number 427, 2048, and I can divide by 2. Will give me 21, 36024. 36024, right? That one. And then you want to reduce again because this is again still the even number. So I can try to divide by 4. Maybe it will be faster, right? So divide the top number by 4 will give me 8, 222, and then 5. Okay, I have 8, 222, and then 5. And then I'll also take the bottom number 1, 2, 3, 6, 0, 2, 4, and then divide by 4. I'll get 53, 406. Okay. And now this one is not an even number because of the 5 at the end. So maybe we can try divide by 5. So let's try that. 8, 2, 2, 2, 5, divide by 5. I'll get 16, 445. And then I'll also divide the bottom number by 5. Hopefully that will work. And we divide by 5. We'll get no, it won't work because of the 6 here. So it cannot divide by 5. So we're gonna try it again. 8, 2, 2, 2, 5. Maybe you cannot divide by 6. 7. Nope, it's not even. How about 8? Not, right? Because of the 5 at the end. How about 9? And then we just keep going. 10, of course, it's gonna not be an even number. And then if not, you can try to do 11. 11 works, right? 7, 4, 7, 5. So we should divide by 11. So now I'm gonna erase this. So we know that on the top we divide by 11. And 11, that means I will get 7, 4, 7, 5 when I divide by 11. And then it looks like that we can divide the bottom number by 11. 5, 3, 4, 0, 0, 6 divide by 11. And that is 45 and then 5, 4, 6. 48, 5, 4, 6. And this is the reduced fractions of this problem.